right, in this video I wanted to introduce you to the idea of taking the moment about a particular axis. I think that this example right here that shows you trying to loosen the lug nuts on a tire make a lot of sense, because when you're doing this, you're trying to obviously make these nuts rotate about a particular axis, an axis that in this picture would be aligned with the x-axis, because any other rotation is not going to help us achieve our goal. So when you're using this wrench here and applying the force in the way that it's shown, if you take the moment about the origin of this axis, and that is if you think about R cross F using your right hand rule, you actually would get a moment here would be the result, this moment about the axis. Notice that this moment has both an x and a y component. So there is some moment being produced by your effort that actually isn't doing anything for you in terms of getting your desired results, which is to make those nuts rotate about the y-axis. So there's going to be situations where we want to know, in a situation where we apply a moment, what would be the moment about a particular axis, because that's the one that's really going to count to us. So for example, like I said, in this problem, we want to know what's the moment about the y-axis. So if you look at that, this one actually you can sort of figure out, because we could use the idea of the moment arm. So if we think about the force being applied, it's strictly in the z direction. And we wanted to find the moment arm, that is the distance from, the axis that we're trying to rotate to, about, to where the line of action of the force is acting. We could find it would just be sort of that distance from along here, right here, which would correspond to, looks like r times the cosine of theta. So we could just find that moment arm multiplied by that force, and that would be the moment about the y-axis for this particular problem. So there are situations where you can sort of figure it out using that approach, but obviously there's going to be more complicated problems where you want to maybe know the moment about a particular line that doesn't correspond to an axis. And it's just not that straightforward or that obvious, like what exactly would that component of the moment be that I want to get at. So we're going to look at what the rules are, sort of the general process that we can go through to figure out how to calculate the moment about a particular axis. So in this picture, we have a very, a very sort of regular or irregularly shaped object, and we have the axis here is AA, it's the vertical axis, and we're thinking about just an arbitrary force being applied at some point on this object. We're going to find the moment about the origin, and then you can see right here is the moment that you've created. But maybe I want to know what is the component of that moment about the vertical axis, which we're going to call the A-axis. So what's the first step to doing this, to figuring out our desired moment about an axis? The first thing that we do is we choose a point on the axis and we find the moment about that point. So for instance here, in this problem, choosing a point like the origin is just fine because it's along the axis, and we're going to then calculate the moment of our force about that axis. But then we're not done. Then what we want to do is we want to find out, well, what is the sort of the component of our moment that is parallel to our axis? Now, this has to do with something that we've talked about in class. It was actually one of the problems in Chapter 2 that you did in class, and we talked about it at the end, and I did a video of an example from class the other day. And that is, how would we use the dot product to find the projection of one vector onto a particular direction? So that's exactly what we're going to do. Notice here we have the moment about the origin, but we want to know the projection of that onto the axis. That's the component of the moment that we're really interested in, because that's the only bit of the moment that is about that axis in question. So the way that we calculate that is we have to find a unit vector along the axis that we're interested in, and then we dot it with the moment that we just found in step 1. Now keep in mind that the dot product is just going to give us a magnitude. The other name for the dot product is the scalar product, so it gives us a scalar. If I wanted to find the vector for that, I would just multiply that quantity then times the unit vector itself, and then that would be able to write it in unit vector form. So in order to make this a little bit more clear, I thought I would look at an example from our book of calculating the moment about a particular axis. And now in this problem, clearly, because our axis is AB, it's not, very defined. It's just some slanted line that's in the XY axis. So following what I say that I like to do a lot, I'm going to find the coordinates of B and A and C and write them down so that I can sort of keep everything straight. Looking at this, point B it's along the y-axis, and so it doesn't have an x component. It's at the front of the box if we view the back of the box lying along the x-axis. So the box in its dimensions in the y direction are 3 feet. So its y coordinate for point B is 3, and it's on the y-axis, so its z coordinate is 0. And so that's fairly straightforward. Now for A, I'm going to try to figure out its coordinates. For A, it is on the x-axis, and so the length of the box along the x-axis is 4. Because it's on the x-axis, it doesn't have a y-coordinate, or its y-coordinate is 0, and it also doesn't have any z-coordinate, or its z-coordinate is 0. All right, so that's good. And then the other point that I'd like to know is this coordinate of C was going to come in handy. The coordinate of C, it's right above A, so it has the same x-coordinate. Its y-coordinate is 0 because it's on that xz plane, and it's 2 feet up, and so it has a z-coordinate. Sorry about that. It has a z-coordinate of 2. So, sorry. All right. So I want to figure out the moment about AB. So there's a couple different things I'm going to want to do. First, I'm going to want to choose a point on AB, and I'm going to find the moment about that point. I am going to find the moment about A because I just think it's easy, because if I do the radius vector, it's going to be the radius vector that goes from A to C, and then multiply that or cross that with F. Now A to C is going to be a pretty straightforward vector. And we're just going to start writing this in unit vector form to find that cross product. Going from A to C is just straight up. That vector just goes straight up along the side of that box. So it only really has a z component, and it's 2 feet long. So it has 0, x, and y coordinates, and its z coordinate is 2. And then my f, I have written here, is 55, minus 40, and 30. And so this is how I'm going to start off, by writing the moment about a point that I chose that was on the line that I'm interested in finding the moment about. So I found a point on the line, I chose point A. And so now I'm going to go through and find the cross product that's found by taking the determinant of this 3 by 3 matrix, which I am going to do through expanding about the top row. If you need a review on that, I did post a video on perusal to review that for you. I'm not going to review it right now. So I have actually just two components of this of this moment. So that's the moment about A. And now what I'm going to want to do is I'm going to want to take the moment about A and dot it with a unit vector that is parallel to AB. And so that's going to take a little bit of work. First, I need to find a vector that goes from A to B. And so I'm using my coordinates for A and B. And so I'm going to have 0 minus 4, because I'm going to go B minus A coordinates. And so I end up finding that the vector that goes from A to B has the components of -4 in the x direction and 3 in the y direction. The magnitude of that vector is 5. And so the unit vector AB is going to be -4/5 I plus 3/5 J. And so multiplying these two together, I get 80 times -4/5 plus 110 times 3/5. And this gives me together the magnitude of that moment is 130. So basically it's saying that the component of the moment, so this moment, the component of this moment that is parallel to the line AB has a magnitude of 130. So this obviously would have a magnitude bigger than that, but 130 of it, it would be foot-pounds, would be parallel to this diagonal line AB. Now it actually asked me to express this as a vector, and so what I need to do to express it as a vector is I need to take what I just got, the dot product of the moment and that unit vector, and then I actually multiply it by the unit vector again. So it has a magnitude, and then this is its direction. And so if I substitute in this right here for the unit vector, I end up with these x and y components. And that is how I can find the moment about any arbitrary axis. Remember, it's pretty simple that it's just these series of steps that you always would do. You choose a point on the axis that you want to find the moment about. Choose one that's going to be easy to find the moment. Like a lot of times it's going to be the origin. In this particular case, it was really easy to use point A. Once you find that moment about a point on the axis, dot that with the unit vector along the axis that you're interested in. That'll tell you the magnitude of that moment along that direction. If you want to write it as a vector, then multiply that magnitude times the unit vector that is parallel to the axis. So it's really just a 3-step process. Hopefully that helps.